Imagine stepping out of a spacecraft onto another world. You are wearing nothing but your street clothes. No helmet, no suit, no protection at all. What would happen? How long could a human survive there without advanced protection? This isn't just a thought experiment. It's a cosmic journey that reveals just how special our own planet is. We will take a tour of our solar system, sun-scorched plains of Mercury, rust-red deserts of Mars, crushing depths of Jupiter, frozen wastes of Pluto. Each stop will answer one simple, terrifying question. How long do you have? The universe is not built for us. It is vast and indifferent, filled with extremes our fragile bodies were never meant to endure. On Earth, we are perfectly adapted. Temperature, pressure, chemistry. We take for granted the air we breathe and the water we drink. But leave this cradle, and the rules change instantly. Before we venture into the deadly void, let's establish our control group, Earth. This is the only place in the entire known universe where we can survive without a machine keeping us alive. Our planet provides a perfect, life-sustaining bubble. Its systems work in harmony to create a haven for biology. The most important of these is our atmosphere. It is a rich blend of nitrogen and, crucially, about 21% oxygen. We can breathe it. It's the fuel for our cells, the very essence of our metabolic fire. Without it, consciousness fades in seconds, and life ceases in minutes. Next, consider the pressure. At sea level, Earth's atmosphere pushes down on our bodies with a force of about 14.7 pounds per square inch. We don't feel it because the pressure inside our bodies pushes out with equal force, creating a perfect equilibrium. This atmospheric pressure is what keeps our bodily fluids, including our blood, in a liquid state. If that external pressure were to disappear, the results would be catastrophic. The delicate balance that keeps us whole would be broken instantly. Earth's pressure is not just comfortable, it is fundamentally necessary for our biological integrity. Then there is the gift of liquid water, made possible by Earth's survivable temperatures. Our planet orbits the sun in a region astronomers call the Goldilocks zone. It's not too hot and not too cold. This ideal position allows water, the solvent of life, to exist as a liquid across much of its surface. We can drink it. It forms our oceans, our rivers, and the clouds in our sky. Let's begin our journey with the planet closest to the sun, Mercury. This small, rocky world is a place of brutal extremes. It has almost no atmosphere to speak of, just a thin, transient exosphere. This means there is no air to breathe and effectively no air pressure. Stepping onto Mercury's surface would be like stepping into the vacuum of space. The lack of pressure would cause the fluids in your body to boil away, a gruesome process called ebulism. Your consciousness would slip away in about 15 seconds. Your estimated survival time, you're under 2 minutes. Mercury's proximity to the sun creates a dramatic temperature split. In direct sunlight, the surface can soar to a blistering 800 degrees Fahrenheit, 430 degrees Celsius, hot enough to melt lead. Stand in the sun and you would be cooked in an instant. But with no atmosphere to trap heat, the nighttime side plummets to 290 degrees Fahrenheit, 180 degrees Celsius. If you were in the shade, you would freeze solid. The only mild temperatures exist in a narrow twilight zone, but even there the lack of air and intense solar radiation would be your end. Now let's turn to Earth's supposed twin, Venus. From a distance it looks serene, a brilliant white jewel in the night sky. But beneath thick, swirling clouds lies the most hellish surface in the solar system. Venus's atmosphere is over 90 times denser than Earth's. Surface pressure is equivalent to being 3,000 feet underwater. An unprotected human would be crushed into a pulp instantly. Like a tin can under a hydraulic press, there would be no time to register it. This crushing force is the first and fastest killer. Even if you could survive the pressure, the environment would still destroy you. The atmosphere is 96% carbon dioxide, unbreathable and toxic. A runaway greenhouse has turned Venus into an oven, about 900 degrees Fahrenheit, 475 degrees Celsius. That's hotter than Mercury, and the heat is uniform day and night. The clouds aren't water, they're sulfuric acid. On Venus, you would be crushed. On Venus, you would be cooked. On Venus, you would be dissolved. Estimated survival time, less than 1 second. It is, without a doubt, the most instantly deadly surface of any planet. Venus makes Mercury look friendly, so today, we're ranking every planet by one question. How long could a human survive there without advanced protection? We'll assume no spacesuit at first, then explain whether future technology or terraforming could ever change that. Next stop, Mars. The red planet has long captured our imagination as the next frontier, a potential second home for humanity. But make no mistake, without a suit, Mars is utterly lethal. Its atmosphere is the first major problem. It's incredibly thin, less than 1% of Earth's atmospheric pressure. This is far below the Armstrong limit, the point where water boils at human body temperature. So just like on Mercury, the low pressure would cause the saliva on your tongue to boil away, and the moisture in your lungs to boil away. Your blood, however, would remain liquid due to the elasticity of your blood vessels, but it wouldn't matter for long. The air on Mars is also unbreathable. It's composed of about 95% carbon dioxide, with only trace amounts of oxygen. You would lose consciousness from hypoxia, lack of oxygen, in about 15 to 20 seconds. After that, your body would succumb to the combined effects of the near vacuum. Your estimated survival time before permanent harm and death is around 2 minutes. This is longer than on Venus or Mercury, but it is a harsh and unforgiving death. Mars is not a place where you can just hold your breath and be okay. Our journey now takes us to the giants of the outer solar system, beginning with the king, Jupiter. Jupiter has no solid surface to stand on. It is a gas giant, a colossal ball of hydrogen helium. Step out of your ship and you would simply fall. You wouldn't land, you'd descend into an endless, turbulent atmosphere. First, you plummet through upper cloud decks of ammonia ice. Temperatures here are a chilly 220 degrees Fahrenheit, 140 degrees Celsius. Winds top 300 miles per hour, tossing you in a violent, freezing storm. Fall deeper and conditions get exponentially worse. Atmospheric pressure climbs at a staggering rate. Within a few hundred miles, the pressure would crush you. At the same time, temperature rises dramatically. Hydrogen becomes so compressed, it behaves like liquid metal. Temperatures exceed the sun's surface. Pressures are millions of times Earth's. You would be crushed and vaporized. No survival, only minutes until lethal death. Next, the ringed planet, Saturn. Like Jupiter, Saturn has no solid surface. It's a world you fall into, not stand upon. Its upper atmosphere is even colder, about 285 degrees Fahrenheit, 175 degrees Celsius. Saturn's standout feature is its incredible wind speed. Near the equator, winds exceed 100 miles per hour. You'd be swept in a supersonic gale through hazy yellow clouds of hydrogen helium. The descent mirrors Jupiter. Pressure and temperature climb to unimaginable levels. Saturn's rings are breathtaking, countless particles of ice rock, but the planet itself is a death trap. Continuing outward, we arrive at the ice giant starting with Uranus. This strange tilted planet is another world without a solid surface. Its atmosphere is a frigid mix of hydrogen, helium, methane, which gives the planet its pale cyan color. The tops of the clouds on Uranus are among the coldest places in the solar system, dipping down to minus 371 degrees Fahrenheit, minus 224 degrees Celsius. Exposure to this extreme cold would cause instantaneous frostbite and rapid freezing. Uranus is famous for its extreme axial tilt of 98 degrees. It essentially orbits the sun on its side. This results in the most bizarre seasons imaginable, with each pole facing 42 years of continuous sunlight, followed by 42 years of complete darkness. As you descended into the atmosphere, the pressure would rapidly increase, crushing you. Deeper inside, the methane, water, ammonia are thought to exist in a hot, dense, fluid state, sometimes described as a supersonic ocean. You would be destroyed long before you ever reached this exotic interior. The estimated survival time is fleeting, a few moments of falling through a freezing, crushing sky. Our final planetary stop is Neptune, the farthest planet from the sun. This deep blue world is another ice giant, similar in composition to Uranus, but even more extreme. Neptune is a dark, cold, and incredibly windy place. It holds the record for the fastest winds in the solar system, with supersonic gales raging at over 1,200 miles per hour. An unprotected human would be torn apart by these winds while simultaneously freezing in the -353°F, -214°C upper atmosphere. There is no ground to stand on, only an endless fall into oblivion. While not planets, several other bodies in our solar system deserve a mention in our survival tour. First, Earth's own moon. It's close and familiar but deadly. The moon has no atmosphere, meaning you face the same threats as in the vacuum of space. Embolism hypoxia. You'd have about 15 seconds of useful consciousness. Temperatures swing from 260 degrees Fahrenheit, 127 degrees Celsius, in sunlight to 280 degrees Fahrenheit, 173 degrees Celsius, in the dark. Micrometeorites, unfiltered solar radiation. Estimated survival under 2 minutes. Next is Titan, Saturn's largest moon. Titan has a thick, nitrogen-rich atmosphere, denser than Earth's. Surface pressure about 1.5 times Earth's. Survivable. 2 fatal catches. No free oxygen to breathe. Brutally cold, about 290 degrees Fahrenheit, 180 degrees Celsius. Methane, ethane, rivers, lakes, asphyxiation. Freezing with a heated suit and an oxygen mask, you could walk on Titan without a full pressure suit. Europa, a prime candidate for life, but not for survival. An airless, icy world, you'd face the vacuum of space. The real killer, intense radiation from Jupiter's magnetosphere. An unprotected human would receive a lethal dose in hours or minutes. The surface is also extremely cold, around 260 degrees Fahrenheit, 160 degrees Celsius. Below the ice may be a vast liquid water ocean, but the surface is a death zone. Finally, we travel to the edge of the solar system to visit the dwarf planet Pluto. This small, frozen world has a very thin, temporary atmosphere of nitrogen, methane, carbon monoxide. After our grand tour of the solar system's most hostile environments, it's time to rank them. This list isn't about which planet is best, but which one would grant you the longest estimated survival time without any protection. It's a grim countdown, a measure of how quickly each world would delete you from existence. At the top of our list, as the least instantly deadly, are the worlds where you might survive for a minute or two before succumbing to the environment. The rocky worlds with thin or no atmospheres cluster together. Mars, the Moon, Mercury. The primary killers are the lack of breathable air and the near vacuum of space, which lead to rapid unconsciousness and internal damage. Temperature and radiation are secondary threats that would finish the job. Of these, Mars is arguably the safest, with moments of tolerable temperatures and slightly higher pressure. They are all exceptionally deadly. In the middle of our ranking are the ice giants and the dwarf planet Pluto. Pluto, Uranus, Neptune. On Pluto, you would freeze solid almost instantly in the cryogenic temperatures. For Uranus and Neptune, the term survival barely applies. You would be flash frozen while being torn apart by supersonic winds as you fall into a crushing abyss. The gas giants are in a similar category. Jupiter, Saturn. There is no surface, only a fall into ever-increasing pressure and temperature that guarantees you are both crushed and incinerated. At the absolute bottom of the list, the undisputed champion of lethality is Venus. This journey through our solar system reveals a profound and humbling truth. We ranked these worlds from bad to worst, but the reality is that they are all fundamentally hostile to human life as we know it. We debated whether you would last 1 second or 2 minutes, but the outcome was always the same: death. We exist because of a delicate, improbable confluence of factors: the right distance from the right star, the right atmospheric composition, the right pressure, the presence of liquid water, a magnetic shield. Take away just one of these, and paradise becomes a wasteland. The dream of terraforming, of bending another world to our will, is a testament to our ambition. But our survey shows just how monumental that challenge would be. Cooling Venus and removing its atmosphere is a project of geological scale, far beyond our current capabilities. Making Mars habitable would require thickening its atmosphere, warming the planet, protecting it from radiation. A project of centuries, if not millennia. The gas and ice giants are simply untamable. Our future in space will depend not on changing planets, but on building small, sealed bubbles of Earth to take with us. We look up at the planets as points of light in our night sky and see worlds of wonder, mystery, and scientific intrigue. They are beautiful, they are fascinating, but they are not for us. Our bodies are calibrated for Earth, and Earth alone. The gentle embrace of our world is replaced by lethal realities. A simple breath could freeze your lungs. Pressure could crush you flat. Pressure could make your blood boil. Sunlight could cook you. Our journey will rank these worlds by raw hostility. We will start with places that might give you a minute or two, then move to those that would end you in the blink of an eye. This is a survival guide to the unsurvivable. Pressure, temperature, radiation, the brutal absence of breathable air. The science is real. The dangers are the laws of physics applied to the human body. Prepare for a trip where the destination is often instant oblivion. Think of it as the ultimate stress test. Thin carbon dioxide atmosphere of Mars, the hellscape of Venus, swirling storms of the gas giants, no ground to stand on. This tour isn't about finding a new home, a paradise island in a deadly cosmic ocean. Let the countdown begin. Finally, Earth provides a shield. Our planet has a strong magnetic field generated by its molten iron core. This invisible force field deflects the most energetic particles streaming from the sun, known as the solar wind. Our atmosphere then acts as a secondary shield, absorbing much of the remaining cosmic radiation. On other worlds without this double-layered protection, an unprotected human would be bombarded with high-energy particles that shred DNA and destroy living tissue. On Earth, we can walk under the sun. That simple act is a luxury not afforded by any other world in our solar system. Earth is not normal. Earth is the lucky accident. Compared to the rest of the solar system, this planet is basically the luxury hotel. But Mercury is only the beginning. Mars is deadly, but it gives us one thing the others do not: hope. And then we reach the planets you cannot even stand on. But the strangest world might not be a planet at all. It is the only terrestrial planet that combines multiple methods of instant death. Crushed by unimaginable pressure, cooked by lead-melting heat, suffocated by a toxic atmosphere, there is no brief window of consciousness. There is no falling. There is only instant, total annihilation. The estimated survival time is less than a second. It is the solar system's ultimate death trap, a stark warning of how wrong a planetary environment can go. So, if you want the honest answer, Earth is not just home. Earth is the one planet in the solar system that does not immediately try to delete you. Which world should we visit next? Titan, Europa, Mars, or Venus? Subscribe for more science survival journeys through space.